Hi, in the last video we learned that a difference of two squares is factorizable. In this video we see that both the sum and difference of two cubes are also factorizable. As usual, let's start by looking at the general pattern. Here we have a sum of two cubes, a cube plus b cube. Again, remember, a can represent more complex expressions. Anyway, a plus b cubed, this sum can be factorized as a product of a plus b and this trinomial, which is a squared minus ab. So notice, if this is plus, this is minus. A squared minus ab plus b squared. Likewise, if we have a difference of two cubes, a cubed minus b cubed, then this is a minus b, this is the first factor, times this trinomial, a squared plus ab plus b squared. So it should be fairly easy to demonstrate that these are correct. So I'll do this first one for you. So as usual, we multiply a by all of this and then b by all of this. So this becomes a cubed, and then a times a minus ab gives us minus a squared b, and then a times b squared gives us plus ab squared. And then we go to the b, that's b times a squared, which is plus a squared b. Right? B times a squared is the same as a squared times b. And then we have b times a negative ab, which is minus ab squared. And then finally we have b times b squared, which is plus b cubed. So it should be clear that minus ab squared plus ab squared gives us 0. And that plus ab squared minus ab squared also gives us 0. So this leaves us with a cubed plus b cubed. So I leave it to you to expand this expression here and see that it is identical to a cubed minus b cubed. Alright, so let's look at some examples. In this case, it should be obvious that we have a sum of two perfect cubes. So let's write this expression so we can see that there are two perfect cubes. That's w cubed plus 1 cubed. Remember, 1 times 1 times 1 is 1. And so then we can apply this expression, this identity, in a straightforward manner. So this becomes w plus 1 times, and just follow this, w squared. Notice it's the first term squared minus the product of the two terms. So that's w. And then plus the last term squared. 1 squared is simply 1. So here we have factorized this expression. Again, here in this case we have a difference of two cubes. So this is x cubed plus, minus 4 cubed. And so then we just apply this identity here. So that becomes x minus 4. And then notice it's the first term squared, so that's x squared. And then plus the product of those two terms, so that's an x and a 4, so we write that as 4x, and then plus the last term squared, so that's a 4 squared, which is a 16, and voila, this is now factorized. Again, here we have a sum of two cubes, so we can rewrite this as 3x quantity cube plus 1 cube. So we can see, right, in a straightforward manner that this is the sum of two cubes. And of course then we just use this expression here, this identity, and we see that it's a product first of the sum of these terms. So that's going to be 3x plus 1 times the first term squared. 3x squared is 9. 3x quantity squared is 9x squared. So we're squaring all of this, minus the product of 3x and 1, which is just 3x, and then the last term squared, which is just 1. And again, we have factorized our sum of two cubes. And again, here we have a difference of two cubes. So let's rewrite this so we can see. This becomes 2w cubed minus 5y, everything to the third power. And we write this again, it's what? A minus b, so it's 2w minus 5y times, well, it's the first term squared, so that's 2w quantity squared, that gives us 4w squared. Then we have a times b, so that's 2w times 5y. And so remember, it's a plus. So it's plus 2w times 5y, which is 10wy. And then we end up with the last term squared. So that's 5y squared. Notice this last term, b, ends up here squared. So that's 5y quantity squared, which is 25y squared. And that's it. We have factorized this expression. Thanks for watching this video. That's it for now.